Greetings everyone, my name is Mike Barrett, and this is part 3, Actions and Strategies of Adaptive Management Project for AMU Class EVSP501, Environmental Management. This presentation will reiterate the project's vision statement, cover 4 possible alternative actions to achieve objectives, and discuss the criteria used to continually evaluate success. Here is again the project's vision statement. The why are we doing this? Before discussing courses of action, a few preliminary background facts that were used in determining alternatives need covered. Horvath and Sauknay stated in their journal that optimum orientation to harness maximum solar energy in the northern hemisphere is to the south, since they point toward the equator and absorb maximum sunlight. After survey, it was determined that the Nellis maintenance buildings that we want to install panels on have about 210,000 square feet of available roof space, half of which is facing south, for a total of 105,000 square feet. We won't consider north-facing surfaces for installation at this time, in order to maximize efficiency while we evaluate our success. In Las Vegas, we can expect to produce 1,570 kilowatt hours of energy for each 1 kilowatt of capacity in a solar array, the common size of which is 400 square feet, giving a capacity of about 5 kilowatts. And finally, solar installation in Vegas is averaged at 232 per watt of capacity. All these numbers were analyzed in determining our alternatives. We will now discuss the chosen plan and some alternative courses of action. Note that each plan will be reevaluated every year to see how well we match with the averages researched, and determine needed corrections and improvements. The proposed project involves a phased rollout. We will install panels on only 2 out of the 8 buildings and use only half of the available roof space. This will mean a small upfront installation cost, meaning fewer dollars unnecessarily used should our savings targets not be met. There's also space left on the building for maintenance of the panels and other repairs. Fewer panels does mean more sides of the panels for the birds to get under, so deterrents will need carefully installed and maintained. The first alternative is to install panels over the entire south-facing roof surface of the 2 buildings chosen in the first plan. This would mean fewer bird deterrents, since there will be fewer entry angles if they cover the entire roof, and a higher solar volume absorbed that we can evaluate our numbers against. However, it would mean a higher installation cost, and no space wrong, and some of the panels need to be removed in order for personnel to access it. The second alternative is to install panels on all 8 of the buildings, but use only half of the roof space. This gives us a high volume of data to evaluate, while still being a phased rollout, plus a greater geographical range to determine the nuances and differences between the buildings if there are any. However, it would be a very high installation cost, coupled with the extra needed bird deterrents shown in the first proposed plan. There were other alternatives discussed prior to this presentation, but they were eliminated due to practicality. To evaluate the success, we can consider the plan successful if 3 conditions are met. We will generate at least the Las Vegas average of 1,570 kilowatt hours per 1 kilowatt of capacity. We will achieve an energy savings of at least half the installation cost in 10 years. Since maintenance is around the clock and energy-intensive activity, we can't expect the system to pay for itself in the typical 7-year time that a typical residential system would. And finally, the routine upkeep costs do not exceed that quoted from the panel manufacturer, which we'll receive at time of installation. And finally, here are the references used in this presentation. Thank you all for your time.